Hey everyone, Dr. Anna here, and we are going to continue the rocks, fossils, and time module. And this is segment 6 in that. And we have to start here with the regression. Remember, in the last segment, I finished transgression, and now we are at the regression. So if I go here, get my pen working. So the regression is the opposite of transgression, and that just means that the sea level is going down instead of going up, like during a transgression. Going down, so that just means that the continent is getting larger and the ocean is getting smaller. It will produce a continuous shift of environments and their sedimentary products toward the sea. It also means that the deep water sediments will continuously be overlaid by shallower water sediment. On the other hand, if you look at individual rock units, they will become younger in seaward direction. But it is the so-called regressive facies pattern instead, like what we talked about during the transgression part. So now we're going to go and I have to draw it. So here is the regression, and I'm going to draw the basin again. I want to make sure that I have enough room. So we're going to do again 3 stages of sea level. So I'm going to start pretty high up because it's regression. So we're going to lose C. So that's sea level 1. As you can see, this here is the land area and this is the sea. This is where the deep water is. So this is where the deep water is. So I'm going to have to start here with the highest energy sediment, which is the pebble. Put it down just to make sure. Then it's continued by the sand, and that will go into silt. And then at the end, we're going to have the clay. That's the deepest water sediment, and that's always going to be in relatively deep water. And of course, that goes all the way. So this is at sea level 1. Now the sea level is going down because it's regression. So I'm going to change the color of my pen. I can do it like green. So this is going to be sea level 2. And now at sea level 2, this is where the pebbles are going to be because now that's the beach. So that's the highest energy level environment. Then it comes into sand. After the sand comes the silt. And in the very deep water, it's going to be clay. And now we're going to see what happens at sea level 3. I'm going to change the color again. It will be, let's say, yellow now. So sea level 3. And now I have to also draw the sea level itself. And see now this is the place where the beach is. So that's where the pebbles are going to be. Here is the sand, the silt, and then the clay. I think this came out pretty good. So it makes more sense if I just erase the previous sea levels. So now you can see that this is the last sea level. So that clearly shows us the land itself got much bigger. Land increase because the sea level is going down. Remember, sea level is going down and the ocean area is getting bigger, obviously. So if we look at the individual sediment, see here the pebble is right here, and then the second sea level put the pebbles right here, and the third one put them right here. So you can see that the same sediment is moving toward the sea and getting younger toward the sea because this was 1, 2, and 3. And if we look at the silt, it's the same thing. So here, here, and here. You see, so the silt is also getting younger toward the sea instead of toward the land. So this is what we call time regressive sequence. So the age of the different facies is changing from place to place because the sea level is going down. Now, if we're going to make a borehole right here and see what happened here, what you can see is that it started with clay, and I'm just going to do it with yellow. And then it goes into silt, and then it goes into sand, and then pebble. So when you have a regression, the grain size of the sediment is coarsening up. So what is really characteristic for regression? That the individual type of sediment or facies is getting younger toward the sea, and that the sediment in a borehole is going to be coarser as we go upward. Okay. And the most important thing that the land is increasing and the land is increasing and the sea is decreasing. And this is what we call time regressive sequence. That's just the same kind of drawing like what I just did. So this is the highest energy sediment. And as you can see, it's changing from the land. Of course, this is the land. I have to change the color. Let's go to gray. So this is the land here. That's the sea. And this is the highest energy sediment, the pebble. So as you can see that as the sea level is going down, the pebble is getting younger toward the sea. The sand is getting younger toward the sea. So you can kind of almost see how the regression is happening. Okay, so now we are at the Walters law, and I have more writing here. When we talk about the Walters law, it is really important when you do research in geology. The reason for it is because if you want to find water, oil, gas, or coal, you need to make drills and you have to walk the area to see what kind of sediments are there. So I'm going to show you a picture here very quickly again. So if you look at these facies and then the sand, then the silt and the clay. I'm going to change the color. It's going to be tricky because you have to tell me what is it, transgression or regression. And then I draw one more, change the color, blue. So right here. I don't really have much room. But what Walters figured out that instead of walking the whole sedimentary basin, which is a long ways to see what kind of sediments are in this sequence, you can just drill a borehole and then you will see that we have pebbles, we have sand. See the borehole here? That's the layers in the borehole, like pebbles, sand, silt, and clay. So what kind of sequence is this? Yes, you're right. It's a regression. So if you see the different facies in the borehole, you can see that it's the same kind of sediments as if you walked along this whole basin. You're going to see the pebbles, the sand, the silt, and the clay. But if you just drill one borehole, you're going to see the same thing, pebbles, the sand, the silt, and the clay. So therefore, you don't have to walk so much. It just gonna do the same thing in one borehole. So he noticed that the same facies have formed laterally were also present in the vertical sequence. And this is what we call Walter's law. So Walter's law helps researchers because they don't have to walk hundreds of miles. All they have to do is just drill a couple of boreholes and they will see the sediments vertically or the sedimentary facies vertically repeats exactly what's going on laterally. So this is a very important law and it's very commonly used in geologic researches. So now we are at the sedimentary cycle, and this is also very important to recognize that. I did this for my PhD. This was my job. I had to go and draw and recognize and measure sedimentary cycles. So we have a borehole. That's what I worked with. I worked with boreholes. So you're gonna look at the sediment in the borehole. This place there is an erosion, and after the erosion, it starts with pebbles. Then it goes into sand. Then it goes into silt. Then it goes into clay. Then it goes into silt, followed by sand, followed by pebbles, and then an erosion. Then it has some pebbles, and then sand, silt, and then clay. Then it goes into silt, and then into sand, and then pebbles, erosion. So what you can see after I drew this borehole and the sediments in it, that right here it starts with an erosion, and then it goes into clay all the way to clay, and then it goes to another erosion. So altogether, this is what we call a sedimentary cycle. And at, at the middle of the clay is what we call the peak transgression. That's where the water is the deepest. Transgression. I just leave it like that. And wherever there is the erosional surface is what we call the peak regression. Okay, so peak transgression at the deepest water sediment. Peak regression is at the erosional surface. So peak transgression, peak regression, sedimentary cycle. Now, if you look at this, I drew another one. See, starts with the erosional surface, pebbles, sand, silt, clay, silt, sand, pebbles. So this is another sedimentary cycle. See, I did two. And you can do it all the way in that whole sedimentary basin. If you drill whole section through there, then you will see the repetition of this sedimentary cycle. Each sedimentary cycle, if you think about, represent sea level changes because the pebble means high energy, lower most sea level. The clay means the deep water, so that's the peak transgression means the highest sea level. Then it goes into the pebbles again, which means it's a regression. So one cycle includes a sea level increase, which means a transgression and a regression. And then the next cycle starts, which means sea level goes up and then sea level goes down. So this is really amazing because we are able to see how many times the sea level went up and down throughout the history of the earth. So this is really, really important. And I guess I'm going to finish this segment right here, and I will start with the sedimentary environments in the next one.